Yeah, glad to be here tonight. Let's see. I don't want to see that screen. Yeah, great to be here tonight and to talk some more of you, and also great that we can do it online instead of coming to Munich again. I hope to be back sometime soon, maybe again during the MCBW, because I was there in May, as Bernard mentioned. And yeah, we'll see where it takes it. And yeah, tonight I'm going to tell you two things. I'm going to talk a bit about Superuse and the theory behind our work, some of our projects where you see it come into practice, and one of the projects that is sort of, dear child of mine, BladeMate, that is going through all these years. It's not going to be chronological, so just bear with me, and please feel free to ask questions in the end. So recently we started to call what we do the architecture of transition, because we see that we are in a phase where society needs to change. We need to transition, and change feels like something sudden. Transition feels like something that is slow, because the things that we want, the things that we envision, are not going to happen overnight. And actually this year we are a 25-year-old office. So we started in the end of 1997, and we're a pretty small group. I joined them in 2006, so not from the start, but pretty small group working out of Rotterdam mainly, but also I have my place in Amsterdam where I am right now. We have one of us working from the USA and one of us working in China, because the transition that we envision is global. It's not something that is happening only in the Netherlands. And I think that there are a lot of companies that are like-minded to us. And I'm glad, to meet or to have met Bernard, which I think is also like-minded to what we do. And just to be sure that I guess in this group, everyone is aware of climate change, but still, these images, they need to be shown as much as possible so that everybody has the same framework and the same understanding of what it actually means. So it's not just that our planet is heating, but meanwhile, and it is happening because of that, it's because we are using too much materials, too much stuff. And every year, as you can see on the left chart, that date that we have used our year's worth of resources is becoming closer in a year. And this is Earth Overshoot Day for the Netherlands and probably for Germany as well. It's probably in April. So depending on where you are, that changes. And we're actually right now at the point that we're using two planets where we only have one. And while we're doing that, we're also throwing away a lot of value, monetary value, in the stuff that we consider waste. And it doesn't matter at which fraction you look exactly and which number is behind that, but just take from it that if you can find a solution to tackle that problem, there's budget available to do that. So all these things mean that somebody is paying to get rid of stuff that still has value in a way. The only thing is we give it negative value. And because we do that, we are, going towards pretty massive biodiversity losses and local climate changes, which means the species will migrate, and not just animals or plants that can't stand the heat or the drought or these things. It's also the people that will migrate. So actually, the most right-wing parties that are anti-migration should be heavily into climate measures, because that is the main thing that can help to limit migration. Well, politics aside, I'm really happy that there's companies or foundations like the Ellen MacArthur Foundation that help to make diagrams like this that help people understand that it's important to work in small circles, to share stuff, to repair, to reuse, etc., etc. And the smaller you make those circles, the lower the amount of energy that you lose. Same for the Sustainable Development Goals by the United Nations. Really helpful to go for key focal points in your project and say, we're working on these three, and that is where we make our impact. Because it's really hard to do everything in one project. Again, the donut economy model, which is also embraced by the municipality of Amsterdam. And the one thing that always strikes me with these kind of schemes is that they are really legible. They are easy to read, but practice is not as easy as theory, because that safe and just space for humanity and that regenerative and distributive economy is not a perfect circle where you can sort of be in. It's a shifting and moving boundary depending on what we do. And some things might be really hard to achieve. It might be really hard to achieve a social foundation of housing for everyone without the problems that we have in land conversion or biodiversity loss. And that is not answered by these schemes yet. That is something that we, or considering that most of you are also architects, that we have to answer, in my opinion. Well, with Superuse, we look at that in a way to go towards regenerative architecture. So most of the buildings that we have right now, the building stock is conventional. Some of it is green or will be green, and a very small amount you can call sustainable, where basically the damages that are done by the building over its lifespan are neutral compared to the positive effects that it has. But we are looking towards not just restorative buildings, so buildings that undo the damage that they did themselves, but buildings that give back to society, to nature, to maybe also the air around us. And the way we look at that is by making buildings build up in layers, like the Stuart Brand model, where the most important thing is that things are demountable. So you can take apart and you can reassemble infinitely or until a certain material is really end of life. The other thing is a very simple decision tree that we use in the office. Prevent first. So if a client comes to us and he asks for a building, we will first see if we can solve his problem without making a building, which is unlike what architects normally do. But maybe he doesn't need a building. Maybe he needs a different business model, or he needs a different, maybe there's a building nearby that would be suitable and that you can renovate, so you can reuse an existing building and transform it. So it's really weird in a way that we don't necessarily want to build as much as possible, but we want to leave positive impact as much as possible. And the way we do that during a project, looking at materials that we use, is we aim for reused materials, preferably local or regional, depending on what's available. If that's not available, we'll go for bio-based options. After that come the recycled versions, so recycled aluminium or recycled concrete or recycled whatever. It's not necessarily bad, but it's usually better to use bio-based. And if those recycled versions would not have been recycled but reused in the first place, well, that would be even better. And of course, or in most projects, we can't really go around conventional materials still. But if we have to use them, we'll try to go for reusable in the next phase, next life. So we always think about the demolition of our own projects as well, or recyclable, or at least durable. And that means in a normal design process, we add a few steps. So every architect makes a sketch design, but for us, that is not about materials. Usually it's just about how many open and closed surface do we need and how much square meters of what kind of conditions. So that when we make a harvest map, that's for us the tool where we look for materials that are suitable for use. We can sort of fill in the blanks and come up with a preliminary design. And usually that is sufficient to go for or to get a building permit, even when there's a lot of uncertainty still. And the goal is to not lock yourself in with a building permit for a building that is not going to be ready in the next 2 years, because a building process is slow and you might find new information, better materials, better quality, and you need to be able to adapt. And that is what we call, or what we like to call, a dynamic final design. So we know what we're aiming towards, but together with the client and the contractor, we can still change and adapt where we see a better fit than what we had before. And in the end, if it's possible within budget, etc., we'll calculate the environmental impact. And of course, the aftercare, which means that there's a lot of projects that we have had in our hands 2 times, 3 times, 5 times. So we stay in touch with our clients and our projects. Putting that all together in one scheme means that here on the left, you have that reused, bio-based, recycled, conventional decision tree. The reused materials are fed by local harvest, so looking at buildings around you, fed by the Harvest Map platform that we developed years ago and sold also years ago, and by other suppliers that are everywhere. I don't know the exact names for it in Germany, but there will be suppliers for secondhand materials. All that together can go into a project harvest map, so that's your palette of materials that you are able to use, which is informing the design, together with the goals that you set with your client, which is not just a program, but it's also making a statement about the source of the materials that you are going to use. So are you aiming for, let's say, 50% reused, or are you aiming for 100% reused, or are you aiming for 100% bio-based? And if some percent of that is reused, then that is preferable, but still bio-based is most important. Well, all these goals you can make in the beginning, and that is not something that all architects and all clients do or are willing to do. And of course, the other thing is costs, which is still important to monitor because almost everyone has a limited budget. Well, all that together leads to a building team and a contractor and a contract and a building, hopefully. And in the end, a material passport, so that future generations of architects can have the information that we are sometimes lacking right now. Besides all that, we look at 14 different flows in our surroundings that influence the design in some way, or can influence the design. So for example, currently we're still exhibiting at the Biennale in Venice, and in the Dutch pavilion, there are stories about water. And it's about harvesting rainwater or sequestering rainwater on the roofs. And all these things are related to each other because, of course, what a green roof or a wet roof can help to keep heat inside or keep heat out, etc. But being aware of that these flows, not just the user, not just the traffic, and not just the energy, are part of your project can help also to set different goals. Well, one of the first projects where all this came together was Villa Welpelo. It's a modern villa in Enschede in the east of the Netherlands. And it was built for a couple that is collecting art. So they wanted a sort of gallery space where they could show their collection. They also wanted the building to be an artwork, to be made out of waste and be one of the first in the world to have that. So it was a building with a big budget compared to standard social housing, let's say. But nonetheless, it's built for a conventional modern villa price. But meanwhile, 60% of the materials that you see here are reused or taken from sources and had a life before. I'm not going into detail to all of them, but here you can see the harvest map of some of the main materials for this project. And you might wonder, so what is that building elevator doing there? That is actually part of the project. We have integrated the building elevator that was used by the contractor into their modern villa as something that connects their kitchen to their bedroom floor so that they can take one small piece of the kitchen to the bedroom for Sunday morning's breakfast in bed. And it's because we had it. It was available. It was already on site. It was not a loss to use it there. Other things came from, well, the local area. So it used to be a textile industry city. And we found, I'll get back to it later, but steel from a textile machine stored at a local scrap yard. And there's a cable reel factory nearby. And we found lots of cable reels that we were able to use. So for the facade, we've taken these middle slats out of the cable reels. They are without nails. The only thing that they have is some sort of bites taken out of it. You'll see it in the next picture. But that is still reuse that you see, that people could call aesthetic reuse or something like that. But it's more than that. So also the insulation on the inside and the steel structure that you don't see are completely reused. So for the cable reels, here you can see some parts here on the left, for example. where the wood is not perfect. And that's something that we actually like because it gives another story to that facade, to that building. And reusing that wood roughly saved 95% on carbon emissions compared to conventional wooden facade solutions. Then for the steel structure, we use this textile machine, and these beams were just lying around. Sorry. And that steel, we didn't know the quality, which was of course a problem because we wanted to construct a house, we needed to get a permit, etc. And what we were able to do was tell a structural engineer to calculate how much can this steel handle if we assume it's the worst quality of steel that was available around the time of construction of that machine. And if that will suffice, then probably permit will also agree that it will be enough for a house. So that's exactly what we did, and also the way we got it through. And also with reusing the steel that was available, we roughly saved 90% on carbon emissions compared to a conventional new steel building. So this villa was completed around 2008, so well, 15 years ago roughly. It's still standing, the facade is looking good. Of course, it became a little bit grayer, as you could see in the first picture. And you see that, well, these grayish curtains are the curtains that we took from greenhouses, which they use as sunscreens. The cable reels are reused. The window frames are new and proved to be actually one of the most problematic during the construction. But they're still living there happily, and I'm looking forward to see what will happen, let's say in 10 years from now, or even 35 years from now, when the building changes again. Well, more recently, a project that we did in Eindhoven, also somewhat in the east of the Netherlands, where we were asked to renovate an old school building and make an extension to that. And of course, we are happy to do renovation because that is keeping the old buildings intact. But not all functions are suitable in a renovated building. So in this pavilion, where they have a place to do openings and art exhibitions, etc., there is a bar. That's the main function. And it's here sort of on the brink of a workers' neighborhood and the former Philips factory terrains. And I don't know if any of you have ever been to the Dutch Design Week, but that is on this side over here. People that used to work there are now living there, but it's a close visit. It's next to the city center. And this monumental school building was going to be renovated, but over the years, some things changed. Like this hallway was blocked by toilets that were added at some point. And it was not really the school building that it was before anymore. So we changed that, or went back to the original positions and added a building on the schoolyard for the kitchen and the cafe. Again, we made a harvest map, and some of the things we could harvest from the former factory terrains of Philips. Some came a little bit further away, but altogether, most of it was found in the Netherlands within, well, 100 to 150 kilometers from the site. And for the wooden roof beams, we found a former goat shed. So it was standing on a farmland somewhere. And by cutting it, measuring it precisely, cutting it into certain pieces, we could make it a little bit higher to make it suitable for human use to walk under and create that cafe space. And just these few cuts, we of course had to add these metal plates in the middle and a lot of bolts to make it a structural connection again. But we like that kind of expressiveness. And then the wooden beams that are in between are just the beams that were in the farm shed before as well. And everything, the whole thing is demountable. So there are no foundation poles. There are 3 layers of Stelcon sheets, so reused concrete slabs that are for the, let's say, the bottom layer, the structural layer. Then there's an insulated layer, and there's a floor heating layer. So we've reused existing concrete slabs to create a heated floor. Well, this space has now been in use for, I don't know, 5 years or so. And actually here in the back, you see the photographer was busy, but I was also giving a talk for a German thing on television at the same time. So that was quite funny. But yeah, if you are ever in Eindhoven, go for a visit. Or when you're in Rotterdam, stop by at our office. It's also a pretty special place. This is a former subtropical swimming pool. So when we found it, or how it was originally meant, was like this. But at some point it went bankrupt, it closed. And of course, all the water was gone. We already were inside a couple of times because we harvested the plants for our office and some hotels like the Hilton, which were nearby our office back then. But when we came back years later, it was like this. So all the plants that remained were dead. The water was gone. It still looks like a swimming pool, but it feels completely different. It feels like a sort of, urban, what do you call it? Urban photography, where you go into these ruins. But it was still actually in quite a good shape. And it was going up for auction. So we came together with a group of pioneers with a plan to say, can we save this building from demolition? Because normal project developers would demolish it and go for housing. But as you can see in this picture, there's some pretty big apartment buildings next to it that have riverside views right now. And if a developer would build something new there, that would probably be years of conflict with the neighbors about obstructing their views, etc. So we thought we might have a shot at buying that building at an auction. So we found an investor and a couple of pioneers with a plan to transform this monofunctional monster into a circular city of the future. And we actually managed to purchase it with the plan to say, we are not going for one grand design that will take 5 years of construction, and then we have a grand opening, and then we'll see how it goes. We go in with the plan that we are going to transform it steadily and basically see it as a continuous renovation and reconstruction where companies move in, companies grow, companies move out. So we've actually had our office in 3 separate spaces, I think, in this building already, smaller or bigger, either depending on the vacancies that were available or depending on the size of our office at the time. So we shrunk a bit during Corona and rented out one of the other spaces that we didn't need anymore. And over the years, we would like to see all these companies connect their energy flows together, connect their value flows and their physical flows, so that they cooperate, learn from each other, use each other's materials, their waste flows. And for us, of course, as architects, we are mainly looking at the building and the reconstruction of it. So some parts of the former swimming pool are kept intact. This used to be the club. So it was not just a subtropical swimming pool. They also had a disco. And here you see on the right, sort of where the smooth tiles are, that was the dance floor. But the rest was like the swimming pool itself, rough stone tiles. And we didn't need to change that. But we added all the window frames to create climatized office spaces. We kept the VIP booths, but we gave them a new paint job, a new upholstery. And instead of brown, red velvet and brass trims, it is now more a suitable workspace. And some of the paintings, like the weird sort of mermaid over here, we kept, but all the new offices with the reclaimed windows. It gives you nice sort of differentiated views towards the riverfront.
Relativ lang wegen der Belegprüfung.
So with a harvest map of this, you can see that we not only looked at the stuff that we were harvesting and how far away from the building it was, but also where it is applied inside the building and how much carbon we saved by reusing it in that way. So there are, as you've seen now, there are various ways to do harvest maps or to show where your material comes from. And we like to experiment with that. So when we redid the basement and we created a dry lab and a wet lab, so a place where young companies, pioneers can experiment with seaweed, with fungi, with new materials, hopefully suitable for architecture later on. We did another type, also more looking at the carbon savings. And it turned out that by reusing the materials here, we saved enough carbon to be able to go back and forth between BlueCity and Paris, where at that moment, the Paris climate conference was being held. you could go back and forth 652 times. So probably the whole Dutch delegation would have been able to go there for the negotiations, offset by this renovation. Well, finally, a project that is under construction right now and almost finished. The inhabitants just moved in, but they are finishing the building themselves. Is this, maintenance cooperation or housing cooperation called Bosgaard. And what they did, they squatted a former neighborhood center. And let's see, can I do this? Yeah, I can. They squatted a former neighborhood center. And when they were asked to move out by the housing corporation, they said, well, we actually live here pretty happily. We reinstated some of the neighborhood functions because when they squatted it, of course, the neighborhood center was gone. And we are running this urban farming plot next door. So can we find a solution where we can stay here and maybe build the houses for us with us? And actually the housing corporation, so the owner of the land, agreed. And they asked us as architect to help them with that problem. And to do that, we suggested to, of course, keep as much as possible of the existing building and add a small part where 5 studios are inside, where the foundations were strong enough, and 3 extra housing units where there's 4, 4, and 6 dwellings inside, if I'm correct, for the future growth of the community as well. And of course, harvesting these materials means that we look at things in the neighborhood. And this library on the left top was going to be demolished. And it had a really nice wooden structure inside. But the problem we had here is that we wanted to reuse these wooden beams. But the angle of the roof, so the pitch, turned out to be a little bit different than what we had in the permit. So we had to go through a small process of permitting again with the negotiations with all the neighbors. Because before we drew the pitch, we didn't know exactly what kind of material we would find. But here, the whole structure is bio-based and reused. So for the top floor, you can see these parts from the library. And for the lower floors, we have these beams from a gas station that were taken down, cut into pieces, all according to the drawings of the structural engineer. And finally, some of the things that we used that we use a lot actually, are the remnants of our steel industry. So everything that we use, cars, door handles, etc., they're usually cut out of steel sheets, and the steel sheets with holes are thrown away, going into recycling, becoming new sheets of steel. But they're actually really beautiful, usually, because there's a sort of industrialized, beautiful logic behind the way these things are fit into a steel sheet. And here they are used to grow the plants along the facade. So you can see here they are used for the solar shading as well on front of the reused window frames. The whole building is insulated with corrugated steel insulated sheets. They are available as B stock. So I would say this is coming close towards a regenerative building. They are growing part of their own food, not just on the plot of urban farming that they have nearby, but also on their roofs and on their balconies. They have bees on their own site for pollination. They have cheap neighborhood dinners that they host in their own facility. So there's a monetary value involved. There are inorganic flows, there's food flows, there's nature flows, water flows. Sorry, my cold is playing up. And the way we've made the housing units, they're all social housing according to all the also financial rules of social housing in the Netherlands. Which also meant that there was a maximum budget, a maximum cost that you can spend to make these houses. And it helps that the future inhabitants are cooperating with the contractor to do certain finishes themselves. But most important is that their houses are not big. They're relatively small, but they have a lot of shared space. So every house has a very small bathroom, but they have a almost wellness space together with all 19 households. And by thinking in that way, you can really reduce the amount of energy that you use, not just as a family, but as a cooperative of 19 families. Well, while this is under construction, just a couple of months ago, we had a visit from the King of the Netherlands, together with some of, well, not his, but his staff and some of the people from the ministry who wanted to learn more about this way of circular construction, which is really good because that helps to put it on the agenda on a lot of levels. And just a couple of weeks, 1.5 weeks ago, Frans Timmermans also was there to visit. I think he was visiting the German Prime Minister also last week. I don't know if it was news in your country, but it was for us. And yeah, that's the way that we would like to develop future projects. So where all these flows come together, where it's not just about the building itself, but also about the community that is going to use it, etc., etc. I'm gonna talk with you a little bit more about the harvesting principle and the different flows that we look at. And this is a little bit interactive, so feel free to open your mic if you want to join in for some part. So we have a big collection of samples at our office that we have used in past projects or that we are planning to use in future projects. So for example, all different types or a lot of different types of cable reel wood like we've used for the villa. And as you can see, they are all a little bit bent because they used to form a circle, or painted version of the contour sheets, which is possible. And these 5 different flows that we look at, we'll go through it. And first of all, dead stock. Dead stock is actually really interesting. It's always a limited amount, but it's new material that is has been stored for a long time usually, and is becoming worthless all of a sudden. So does any one of you recognize what we're looking at here?
Windshields of a car?
Yes. So, well, Germany has a big car industry. And when a certain car is produced, all windshields for that model are produced in, well, roughly one run. And all spare parts are also produced around then. Because when your windshield breaks, they're not going to produce a new one for you. They will have it in stock. And what that means is that there are shelves with unused windows for almost every brand of car, every type of car. And we were able to get roughly 100 of one of the same kind. They were all Audi windshields. So one size, which means we could make a specific design to reuse that. And here it became the shelving for a shoe store where there was a relatively small shop. So the owner could be in the shop on his own. They didn't have to go back to the storage. They could walk around the shoe fitting island and help customers in that way. And of course, this scale is showing what's possible. It's not creating impact. But in my graduation project, I designed a glass dome over a building constructed out of brick waste, where I would use 1,500 of these windshields, all of the same type. And then you can say that you are making impact. If you can make structural, large-scale designs, and that's what I will also show with BladeMate later on. Well, something that you're probably familiar with, construction or demolition waste, so basically everything that is happening around the architectural field, window frames, doors, etc. They are always available. You know they will be there. And for example, this building was going to be demolished. It was only 25 years old. And it had very nice aluminium window frames, high quality. And we were able to make a deal with a deconstruction company that we could salvage as much as possible without getting in his way. And we got these to make a temporary exhibition for an art center in The Hague, showing cradle to cradle, Superuse, and building likeness as 3 different sustainable strategies for architecture. But of course, after that exhibition, we had, well, window frames, and we were not going to throw them away. So for another commission, we were able to create a temporary meeting space in an office building where they could judge subsidies really quickly by this revolving door where artists would show their work, another one would hang up his work, and they would pitch one after the other. And most of the glass, or most of the window frames that we have left, ended up in the Faculty of Architecture in Delft, where it became the espresso bar after the old faculty burned down, where we also did the espresso bar. Then end-of-life materials. So this is happening all around us. And I think for this part, you really have to help me, because I usually do this calculation for the Netherlands. But washing machines, we have a lot of those. And how many people live in Germany? Is it around 80 million? So let's say that is roughly 50 million households. So probably 50 million washing machines. And that means that if you replace your washing machine every decade, you are throwing away 5 million washing machines a year as a country. And if you throw away 5 million, I'm just going to calculate very quickly. That means you have a little over 13,000 washing machines a day that are thrown away in Germany, which for me as a person, buying a new one every decade doesn't feel significant. But if you imagine a pile of 13,000 washing machines going through Germany daily, that is quite a lot. So if you are aware of the numbers behind these flows, and we didn't calculate this before, so this was a 1 minute assumption on how much you have, then you can start to design with that, and you can start to build with that. And this was the first temporary installation. And as I mentioned before, this was in 2003. We did the espresso bar for the Faculty of Architecture, where it became this project, the first espresso bar, but well, that was lost at some point. But then maybe more interesting as well. Do you know what this is?
Train access?
Like getting close. They're actually the driving shafts of trucks. And there are lots of them, as you can see in this scrapyard. And we got our hands on a few of them to do an experiment to create an alternative bollard for city infrastructure. So this still looks like a rusty bit of steel, but if you clean it, powder coat it, then it can look really nice. And if you put it into some sort of solid foundation, you can make it part of the city fabric. And this is mostly interesting if there would be a company starting to do this just as regular production. That is not up to us, but I think that the design is free for the taking. Well, fast life waste, as I mentioned before, exhibitions, fairs, etc. Well, there will be plenty, also in Munich and around, where you have a really nice installation with an exhibition inside. We were actually part of the exhibition inside this small cubicle. And we said, okay, can we have it after the exhibition? We don't know what we're going to do with it, but it's a shame that otherwise all that nice wood will be thrown away. And we converted it into a meeting space for our office, adding some train windows that we had lying around. And it just proves to show that there is material available everywhere, usually was sort of hidden in plain sight. And you just need to be aware of it. Well, finally, with production waste, there's, again, lots of it. Every industry has a waste flow in their production, either because they are creating excess materials because the client asked for a certain color and they don't want to run out of it while they are still dealing with that order or whatever. But we went to a place like this that were creating these corrugated steel sheets, and we asked for all their leftovers and made a composition with that for one of these industrial boxes around every city. And while we did that, we also bought new conventional doors with safety locks, etc., matching the colors of the materials that we found before. Well, I've shown you the steel contour sheets already. They are part of that as well. So the construction or the industrial waste, which is going in large quantities. But the interesting thing is when you start to use it either in interior architecture for railings along stairs or balconies, or as a backdrop in a modern pantry in an office building, or as a secondary facade to an ugly building that is going to be reused for a couple of years, then you can really create something new that is with an interesting aesthetic very easily. And recently we started delivering this material to other companies as well, like in this example, another Dutch architecture firm, or a rooftop extension terrace, or just a modern office building with nice looking balcony. Okay, I see that I'm almost at the end, but I'm going to switch to BladeMate, so the other part of the presentation. And that is right there. You don't see that. Then I will just new share and go to this. Now you see it, I think. Do you?
Yes, we see it.
Yes.
Yeah. Okay. I'm in my. Oh wait, I have to switch here as well. Perfect. So, BladeMate is a spin-off of Superuse that originated. Well, you could say 2 years ago. You could say 15 years ago. I'll come back to that. But it's a scalable repurposing strategy, and well, there are lots of wind turbines in Germany. Also, these blades are becoming bigger and bigger. But actually, the first generation of blades that is partly handmade, they are, it's a craft to build these things. It's not easy. There's a lot of knowledge and money invested in making it. And currently, we are at the end of life for a lot of wind turbines that are built in the, let's say, early 90s. And that means that the blades become end of life. Also, the towers, the nacelles, the foundation, basically everything becomes end of life, because that generation of windmills doesn't exist anymore. We are not, or most companies are not producing that type or that size anymore. And 15 years ago, we stumbled upon that problem or that opportunity, where my colleague is inspecting these blades to see if they were suitable for architectural designs. And back then, it was definitely still possible to either cut them to small pieces and to put them in the incinerator, or as they do in the States, to landfill. In Europe, we have a landfill ban on glass fiber reinforced polymers, but still burning them is not really a good solution. And with the first 5 blades that we obtained, we were able to build a playground in Rotterdam. So these are 25, 27 meter long blades cut into pieces. You can see one here in full length, but the other 4 are cut up. And the reason to cut them was mainly to remove damages that happened during transportation or other things. So that's why they might have a weird angle like that. And of course, we then try to use the pieces that we had to make a design that would fit nicely around a former concrete slab that was in the playground that we didn't want to remove. Because the reason that we were asked to design a playground was because there was an old playground, rotten wood inside. Well, the way we design these things is that everything should have at least a double function, or preferably. So this is a picnic table, but it's also part of the playground itself, or the big climbing structure. And the inside, we did not design this. We only removed a piece here in the middle. And of course, it was painted. 2 pieces are connected. We added glass fiber, reinforced or glass fiber mats and covering it. And so there's a lot of work done to make it like this. But still, most of the shape, most of the space was given to us by the, let's say, wind turbine engineers who designed the blades in the first place. And again, by doing this, we noticed that with reuse, we can roughly save 90% on carbon emissions compared to making this same playground with the same amount of playing facilities in a wooden structure with stainless steel tubes or stainless steel slides, etc. Since we did this project, we've had some other projects over the years, either with smaller blades, making urban furniture, where the nice thing is with that blade shape changing all the time, there's basically a perfect seat for everyone, every person, independent of your length or width or whatever. And a couple of years ago, 3 years ago, it needed a paint job. And Rotterdam was also looking for a place for a LHBTIQ plus monument. And we decided that 1 + 1 would be 3 and make our former red urban sculpture into that monument. So it's standing there on the square now for 3 years already, and it's still beautiful. It's really interesting that, well, sometimes you hear in the news that things to do with rainbow colors tend to also attract negativity or gravity or whatever, but so far we haven't noticed it in this object. Well, after that, we had another commission for a playground, now on a beach, which is the harsh weather environment that the blades are commonly used to as well. We've added some new things like climbing grips on the outside, which is doable. A different kind of slide, because here we didn't have an original playground to reuse the slides from. And the municipality liked it so much that they also asked us for an artwork on the pier of the harbor, where we reused parts of the same blades, but now carving away an element, making a new piece inside. But it's really nice when you see it like this. It still looks like a sculpture, but when there's a person standing inside, then you can actually see how high it is. And finally, we've reused one of these blades in full without cutting it, without doing any damage to it at all. Even the tip of the blade is standing next to the entrance, showing the opening hours, just as a billboard, a marker on site for that project that you've seen before. Well, last year we exhibited at the Dutch Design Week in Eindhoven, so close to the Kevin building that I showed earlier. And we showed different types of street furniture, urban infrastructure elements that we can make with blades. And with the generation of blades that we have now, we think that these solutions are feasible. But in the next 5 years, these blades will become bigger, also the blades that are end of life. So we should go beyond playgrounds, beyond benches, and beyond all these other small solutions. So what we're working towards now is a sound barrier. And for us, that means something along the highway, preferably with plants inside. I'm just going to skip this really quickly. With plants inside that you can build along highways in high density city infrastructure. For example, let's say the Ring of Munich, the Ring of Amsterdam, all these types of places where pressure on the urban environment is high, and you can create a high quality public space next to the highway, because that is actually the most quiet spot. If you are 100 meters further or 200 meters further, there will be more noise than right here. And while nowadays most of these spaces are places where you don't want to be because they are, well, neglected, hideous, feel unsafe, we think that we can make high quality public infrastructure with high quality public space in one spot, adding the playgrounds, adding the benches as well with material that we don't use. And that is exactly what Bernard mentioned in the beginning, where we got the Pioneer of the Year award for. And I just looked up a few details on Germany, where we said, okay, in Germany, there are roughly 29,000 wind turbines installed, and they are still in their first life, which means that we estimate 4,000 blades per year going to landfill. And currently, of course, there are repair and replace things in place, and that should happen, but incineration or landfill is just not the solution. That should be always a blade-made solution in between before recycling. Also with the new blades that are coming up, where, for example, Siemens Gamesa is claiming to have a recyclable blade. That's all perfectly fine, but still, if it is recyclable, a second life, a repurposing solution, will always yield environmental results that are beneficial compared to recycling immediately, because you are replacing the use of virgin materials for 25 years or 50 years. And basically that helps us to flatten the curve of global warming, of temperature increase. And if we do that on a large scale, I'm really convinced that we can make a big difference. Well, to achieve that, we are building circular value chains right now as BladeMate. This is our circular value chain in the Netherlands with a decommissioner, a big construction company, us as an architecture firm, a small construction company or contractor that does street furniture, etc. Company calculating the carbon footprint of all these things, and somebody that helps with all the stakeholder engagement and all these things around it that you need to manage. And I think that we need localized circular value chains for all of these materials, but for BladeMate, we are actually pursuing that right now, not just in the Netherlands, but also in Germany, Austria, Sweden, Denmark, France, Spain. Well, wherever there are blades, we think we can build such a circular value chain. So thanks. That's what I wanted to share with you tonight. And I think we have plenty of time left for questions.